Hi, and welcome to the video on the start of probability. Okay, so we're leaving our experimental design and sampling methods, which was more like randomness, and we're going to move on to probability. Okay, and to start with probability, we're going to start with random phenomenons. Okay, so basically, when we start with probability, we want to kind of start from the roots of it and not just jump into, theoretical or flipping coins and that stuff. We want to kind of talk about how probability is defined and make sure we're comfortable with all these terms listed on this page. Okay, so let's start off with a random phenomenon, and I'm just going to give my basic, un, you know, unscientific definition. So when I think of a random phenomenon, I just think about a situation that occurs in real life and we're not sure of the outcome. Okay, so let me just talk about a quick example the book talks about, and I think it's a fairly good example, or it's a really good example. And the example is if you leave your house, okay, and you're driving. Okay, so you leave your house and you're driving, and you have a light. Okay, you encounter a light. So the question is, you have this situation that's going to come to the light, and that's you're either gonna make the light, or you're gonna miss it. So this would, if you make it, it's green. If you miss it, it's red. Okay, so this is a situation that happens in real life, and you're not sure of the result. I shouldn't say outcome. You're not sure of the result. I don't want to get you confused with this outcome here. Okay, and you're not sure of the result of that situation. Okay, you have to have at least two. Well, okay, and you're not sure of the result. Okay, so this would be a random phenomenon. Now let's get into a trial. Okay, a trial is basically any time we observe a or encounter a random phenomenon. Okay, anytime we observe a random phenomenon, okay, that's called a trial. So let's say we're gonna my random phenomenon this time will be flip a coin. Flip a coin 5 times and record the number of heads. Okay, so this is our random phenomenon. If you flip it 5 times, that's the situation that occurs in real life, and we're not sure what the result's going to be. You're not sure. Okay, so the end result is random. Okay, so let's just, I'm making this up. Heads, heads, tails, heads, tails. Okay, so that's what I observed. That would be one trial. If I repeat this again and flip it for 5 more times, that would be considered the second trial. Okay, so let's say the second time we get tails, heads, tails, tails, tails. So this would be another trial. So that would be the second trial. Okay, so that's what a trial is. Okay, the outcome at each trial, okay, at each trial, the result of the random phenomenon is the outcome, the result. Okay, so at each trial, the result of the random. Okay, so this situation here would be an outcome. That's one possible outcome. Okay, this result here, the second result, is another outcome. These are outcomes. Okay, now in a light situation, okay, in this case, make or miss. Make or miss. So if you make it, it's green. Okay, if you miss it, it's red. So each one of these is an outcome. Which leads me to the next one, with this event. And this event is probably going to be the most talked about term on this page. Okay, because an event is just, it could be an outcome or a collection of outcomes. Okay, it's an outcome or a collection of outcomes. Okay, and let's talk about that. And you could be looking up in here and say, well, what happens if it's yellow? Well, yellow could mean two things. Okay, yellow, and it depends on how you group it. But yellow, if you hit the gas and run through it, then that would be considered, that would be with the green. Okay, if you hit the brakes, that would be considered with the red. Okay, so that could possibly go both ways, and you'd have to define it. Okay, or let's say we roll a die. We roll a die. Okay, so 1, 2, 3, 4, 5, or 6. This is the list of all. These are all outcomes, right? These are all outcomes. So I could say an event could be roll an even. Roll an even number. Okay, so an even number would be 2, 4, and 6. So that would be a collection of 3 outcomes. That makes an event. Or I could just say an event could be roll a 1, the number 1. Okay, roll a 1. Well, that's just one outcome, but it's still considered an event. Okay, so it's either an outcome or a collection of outcomes in the sample space, which leads me to the next term. This is very, very important. A sample space is a list of all possible outcomes. Okay? Now I say outcomes, not events, because an event could be any combination of these. Okay? An event could be any combination. 1 and 2, 1, 3, 1, 4, 1, 5, 2, 3, 4, 2, 3. So, list of all possible outcomes, the singular outcomes, if you list them all, that's a sample space. And we denote it by a capital S. So in this case, for rolling the die, would be S equals, and we use set notation for the most part, which is this little bracket, and you just list all the possibilities. Okay? Now if you flip a coin 5 times and record the number of heads, okay, now the sample space in this case would be a lot larger. Okay? Because think about it, the S here, I'm just going to do a couple of them. One would be obvious, which would be all heads. All heads. That's one possible outcome. Or all tails. Okay, that's another possible outcome. Or we could have 4 heads and 1 tails. But the problem with this is there's a lot of different ways to have 4 heads and 1 tails. For example, you could have heads, 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 tails, or you could have tails and the rest of them. Heads, heads, heads. So in this situation, there are a lot of different ways. There's actually 5 different ways we could do this. There's 5 outcomes right here. 5 outcomes. Okay, so hopefully you can follow that. There's 5 different ways you could have 1 tail and 4 heads. There's only one way, there's only one outcome. There's only one way you could get all heads. That's heads, 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 heads. There's only one way you get tails, 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 heads. So the sample space here, okay, is pretty large. This is a large sample space, okay? And there's fun statistical techniques to do all this, and you don't have to know all this combinations and permutations to do all this, but just make sure you have a really good understanding of the difference between an outcome and an event, a trial, random phenomenon. Okay, let's go to the next page. Let's talk about the law of large numbers. This is very powerful. This is very powerful. We're going to use this a lot later in the year. So the law of large numbers basically tells us that if we have independent trials, and what independent means is basically means that that one trial doesn't affect the probability of the next trial, or it doesn't affect the chance of the next trial. Okay, so one trial does not influence the next. Okay, like flipping a coin. Like if you flip a coin and that coin flips and lands on heads, okay, that heads does not have any bearing on the next time you flip it. Okay, so if you have as okay, let me write this here, as the number of independent trials increases, and I might have to explain a few of these words. The long-term frequency, so let me say long run. You know, like in the long run, not long term. Same difference, but the long run frequency of repeated events approaches a single value. It's very, very, very powerful. Okay, because we're going to kind of use this in a lot of different aspects. And basically, this is like if you flip a coin, and you do it manually, like you actually flip the coin, and it's a fair coin, let's say it's fair, and it has two sides, it has a heads and a tails. So if you flip it once, let's say we want to measure the probability of getting a tails. And I'm going to talk about this notation later. Probability of getting a tails. So let's just say the first one was a head. Okay, so if I look this on a graph, okay, this is the probability of getting a tails. So if the first one's a head, what did you get? You got 0%. Okay, now what happens if the second one's a tails? If the second one's a tails, that means that it goes to 50%. So this is 50 right there. 50%. These are in percents. Okay, so the first one was 0. The second one was tails. Now let's say you get another tails. So now, see on my third one, I'm 2 for 3. So that's going to go up to 66%. So I go up to 66% on the third one. Now let's say I get another head. So now I'm 2 for 4 for head. So now I go down to 50%. And what happens is this is going to bounce around. It's going to bounce around, and it's going to approach 50%, and then this will just kind of do this right here. It'll approach 50%. And if you look in the book, there's a great example on the light problem that I was talking about. Okay, now let's talk about the probability. Okay, so basically, this single value, obtained the single value obtained, let me write a little slower and neater, from the long-term frequency is the probability. Okay? And let me talk about the long-term frequency for a second, a little more. I did it on a graph right here, but the long-term frequency, or the long-run frequency, is the number of successes over the number of trials. Okay? And we want this to be very large, because it's called the law of large numbers. So we want this bottom to be really large. For example, this is what I'm doing right here. I had 2. I'm interested in getting a tails. Okay, when I was right here, I had 2 tails, which is the number of successes over 3 trials. When I went to the 4th one, I had 2 heads. I'm sorry. What was that? I was interested in tails. So 2 tails over 3. That's correct. So here I had 2 tails and 4 tosses. Each toss is a trial. Okay? So this is the formula for long run frequency. Okay, you should be very familiar with that. Okay, what's the difference between empirical and theoretical? Very important. Everything that I've been talking about up here is empirical. Okay, so this is when we observe a real life event or simulate a real life event and record the probability, or it's a long run probability. And I'm trying to go a little fast because I don't want these videos to be too long. This is when we observe a real life event or simulate a real life event and record the long-term probability. Theoretical is when we model, or let me not say we, let me say a, when a real life event or simulated event is modeled to what we think may happen. Okay? Okay. When we want to figure out the probability or model, when we want to model a probability, there's kind of 2 different ways to do it. And one case is when when all outcomes are equally likely in the sample space, NS. Okay, what we do is we say the probability of some event. Now we generally label events with capital letters, A, B, C, etc. Okay, we usually do these with capital letters. So event A may be 1 outcome, 2 outcomes, 3 outcomes in a sample space, but it would be the number of outcomes in A divided by the number of outcomes in the sample space. So for example, if I said A was getting an even number on a 6-sided die, you guys probably know this already. This is how we denote this. The capital P stands for probability. In the event, you instead of writing even number, I'm going to write A. Okay, so let me come over here. S equals 1, 2, 3, 4, 5, and 6. Okay, so how many numbers are in A? Even numbers on a 6-sided die. Even numbers. So there's 1 even number, there's 2 even numbers, there's 3 even numbers. So there's 3 outcomes in A, and how many are in S? 1, 2, 3, 4, 5, 6. 6. Simplify the fraction, 1/2. So probably you're going to get an even number, and a 6-sided die is a half. Okay, I modeled this. Empirical probability would be I would roll a fair die, say 1,000 times, and record the number of even numbers, or record the number of times I know this is running a little long. Record the number of times an even number landed, okay, and divide by 1,000. Okay, that's each roll is a trial. So it would be the number of evens divided by 1,000. This is empirical. This is a model, okay, which would be a half. Okay, if we do this, we'd have approximately 500. Not saying you would have 500, but you'd have around 500. Okay, so that's the video that gets us started in the probability. I know this is a little long, but if you're having trouble, watch it again. Pay close attention, because you have to be comfortable, because I'm going to be talking in statistical notation, or any teacher, even if you're not my class, even any teacher talks in this type of statistical jargon, you say, and they kind of talk like this. Okay, so you need to be comfortable, so when they say trial, you understand what's going on. If they say outcome, if they say event, okay, you have an idea of what's going on. Okay, so thanks for watching.